Hi guys, we're going to talk about permutations, which are part of this umbrella in math called combinatorics, which is a fancy way of saying counting things. Okay, real talk. The answer to everything in this section is going to be number factorial, right? That is the TLDR version. What's a factorial? So number factorial is 5. 5 factorial is just 5 times 4 times 3 times 2 times 1. So this is going to be 1, this is going to be 2, 6, 24. 24 times 5 is 120. That's what factorials are. The truth is, though, that's not going to be very helpful because permutation and combination problems are very difficult. And what makes them difficult is that you don't know which format you're supposed to use all the time. In these questions, you're always going to have number factorial, right? But I want us to try to understand why that's the case a little bit. So I'll go through some, write the answers down so we make some, you feel good, and then I'll talk about why. So Anthony is shooting targets off the range. If there are 3 targets, in how many different orders can they pop up? So we're going to do 3 times 2 times 1 or 3 factorial. Don't worry, I'm going to explain this. I'm going to explain all of these at once. So 3 factorial, which is just 6. Dahlia is shooting targets in the range. If there are 4 targets, in how many different orders can they pop up one by one? Okay, so I'll start to explain it. There are 4 choices for the first pop-up. Then there are 3 left. Then there are 2 left. Then there are 1 left. But this is not a great explanation. People say that, but it's, why are you multiplying? How do you know it's not 4 times 4 times 4 times 4? It's one of these like fake explanations where you think you get it, right? But it's something, right? So 4 times 3 times 2 times 1 is 24, right? Which is 4 factorial. But again, we're going to give you a real explanation soon. Lily is at the horse racing and is betting on which one will win. If there are 3 horses, how many different outcomes are there? So 3 factorial is 3 times 2 times 1. So let's actually use this one to try to understand. Again, that's just 3 times 2 is 6. Let's try to see if we understand what's happening. We're basically lining up the horses, and we're saying pretend A wins. If A wins, then what can happen? We can have B, C coming in second and third, or we can have C and B coming in. What if B wins? Then we can have A coming in second, C coming in third, or C coming in second, A coming in third. Or what if C wins? Then we can have A coming in second, B coming in third, or B coming in second, A coming in third. So you can see that the answer is 6, right? You can just count 6 here. So the question is, why is this 3 factorial? Well, this is the number of ways you can order 2 letters, right? It's obviously 2. You could also write that as 2 factorial, right? 2 factorial is just 2 times 1, which is 2. But then there are 3 choices for the first letter, right? So we're pretending that the horses' names are A, B, and C here, right? There are 3 choices for the first letter, so it's 3 times 2 factorial, which will be 3 factorial. Now imagine we had a 4th letter, right? Then we could stick that 4th letter, let's just say that were F. We could stick that 4th letter in front of every one of these, and that would give us still 3 factorial, but then we could change for any of those 4 letters to be the first, and it would be 4 times 3 factorial, right? And it would keep going, and that's why factorials grow on themselves like this. So hopefully that's starting to make sense. Really think about this. So 3 factorial is 6. Again, answering these questions is easy, but that doesn't mean that these types of questions are easy. Dahlia plays the lottery and is trying to calculate her chances of winning. If lottery numbers have 4 digits, how many possible combinations are there? This is not a good question. I know the answer is 4 factorial, but that is not a good question. If a lottery has 4 digits, it matters what the numbers in the actual lottery are. So we're going to write 4 times 3 times 2 times 1 because we know that fits this pattern, which is 12 times 2 is 24, but that's not the right answer to this question, even though it's going to be marked right. William's at the horse races and is betting on which one will win. If there are 4 horses, how many different outcomes are possible? Okay, so again, we have 4 times 3 times 2 times 1. So this is 12. 12 times 2 is 24. So we're going to have 24 orders. If Matilda has 5 errands to do, how many different combinations are there in which order she can do them? We should really say permutations when we're talking about orders. So we have 5 errands to do. We'll have 5 factorial orders of arranging them. So we'll have 5 times 4 times 3 times 2 times 1, right? This is 24. We know that. We know 4 factorial is 24. Then 5 times 24 is 120. Joseph is raising chickens in a backyard coop. If he is expecting 4 new chickens to hatch, how many different egg orders can they hatch from their eggs? Okay, so 4 factorial is 4 times 3 times 2 times 1, which is 6 times 4, which is 24. Jacob is raising chickens in a backyard coop. If he's expecting 3 chickens to hatch, and how many different orders can they hatch from their eggs? So you've picked up the pattern here, right? When you're talking about ordering things, it's the number of things factorial. So it'll be 3 times 2 times 1, which is 6. If Ryan has 3 errands to do, how many different combinations, permutations, are there in which order he does them? So 3 times 2 times 1, which is 6 different orders. And Samantha is at the horse races and is betting on which one will win. If there are 3 horses, how many different outcomes are possible? 3 times 2 times 1, which equals 6. Okay, kids, this is one of these lessons that's like a language, right? I remember being in 7th or 8th grade in Spanish class and kind of thinking I was tricking the teacher by using tricks to memorize words. And then later I just didn't know anything. I didn't know how to speak the language, which is a shame, right? With this, it's a very hard topic. Combinations and permutations are a very hard topic. So you really should just try to draw as many pictures as you can, list out every possibility until you get an idea, because that's the only way you're going to get better at them, not by just sort of following formulas. So hopefully you take that to heart. But either way, you've got plenty of time. You've got years. You're not supposed to get this in 1 week. You're supposed to get this it takes years to understand this well. So have a great one and good luck.